All right. Assalamu alaikum and welcome everyone. I'm Huma. I'll be hosting today's webinar on behalf of DICE Analytics. We have Scott with us. I'll be introducing him. He is a data scientist at KNIME. He routinely teaches and presents and leads group workshops covering topics such as KNIME Analytics Platform, machine learning, and the broad data science umbrella. So he'll be delivering today's webinar. Um, in case you have any queries, please feel free to ask your questions in the chat section, and Scott will be answering that along with the webinar.
All right, thank you very much, Huma, for that. She mentioned my name's Scott Fincher. I'm a data scientist on the education and evangelism team here at KNIME. What that means practically is my job, partially at least, is to do events like this to kind of spread the word about KNIME for those of you who may not have not heard about it before. I also do a little bit of teaching, educating, and training about how to use KNIME better for our existing user base. So let's go ahead and get started with what we're going to cover today. Have about an hour with you all. So I'll give you just a brief background on KNIME, the company, and then the software that we offer. We have a few different modeling demos that I'm going to show you today. So there's a classification modeling demo, which involves a little bit of ETL data blending and also some visualization. And I'll show you different ways that we can approach modeling within KNIME. The idea of this talk is we can use not only the KNIME built-in tools to approach the modeling that we want to do, but also some of your other well-known open source data science tools like R, Python, H2O, and Spark. And I can show you how we can do all of that under the KNIME umbrella using very little code, really. And then we'll also, once we build these models out, we'll do a comparison of the results and see how they performed against each other. I also have a deep learning demo with Keras. So one of the nice things about KNIME is we provide some additional nodes that allow you to build neural networks with Keras and TensorFlow, and we can do some image classification. So I have an example about that. If we have time, I don't think we will, but if we do, I'll also have a little bit of a text analytics NLP example that I can show you with KNIME as well. And then I'll try to make sure we have some time at the end for Q&A too. And while I'm thinking about that, let me go ahead and just set my clock here so I don't lose time where we're at. Okay, question in the chat, will the recording be provided or not? Huma, I believe you can answer that. I think the answer is yes. I'm not 100% sure from my side, so maybe she can type.
Yes, we'll be providing recordings after this session.
Perfect. Okay.
Yeah.
So, and just before I forget, thanks again to DICE for hosting and giving the ability to chat with you guys. Okay. So for those of you who may have not seen KNIME before, I'm assuming that some of you probably are not familiar with the tool. I'll just tell you a little bit about what KNIME is. So KNIME, the company itself, was founded back in 2008. We have offices in a few different countries. In Zurich, Switzerland, that's where our headquarters is. And then also just across the Swiss-German border in Constance is one of our main offices. Also, a bunch of our developers are in Berlin in Germany. And then our US staff, which is where I'm located, are in Austin, Texas. So we maintain the open source analytics platform, which is primarily what I'm going to be showing you today. KNIME Analytics Platform is a tool that allows you to blend data together in all sorts of different ways, process and transform that data, do analysis on it, and build and deploy models. The key feature about KNIME is that it's a visual front end. So everything that you're doing in KNIME is going to be using a GUI. Basically dragging and dropping what we call nodes onto a your blank canvas and building out your workflow. Generally not going to be writing a lot of code with KNIME unless you just want to, and then you can. So we can blend all sorts of different data, everything from local flat files, Excel spreadsheets, on your local machine, up through accessing extracts from databases and all the way through big data. Hive, Hadoop, Spark, and that sort of thing. And then, as I mentioned, you have the ability to use all sorts of different tools. So if you're already using Python or R in your analyses or Spark, you can tie that into KNIME quite easily. And I can show you some different ways that you can do that. We've had regular biannual open source releases since 2006. So twice a year, we'll release a new version of KNIME AP, the analytics platform, once in the summer. And then we just had our most recent release just a couple of weeks ago uh, in December. And we're really committed to open source. So if you hear me saying something and you think, oh, there's no way that, KNIME actually does that. That's not, you don't have to believe me, right? You can go and check our code, which is out on Bitbucket and GitHub, verify what I'm saying is true. We really do make our stuff open source and freely available to everyone. That's something that's really important to us. The commercial KNIME server is how we keep the lights on. So people will say to me oftentimes, well, how do you pay the bills if you're an open source company and you're just giving your software away? Well, that's true of the KNIME Analytics platform, but we also have an enterprise version of our KNIME software that we sell to, corporations, right? It's really a complementary tool to the analytics platform. It's going to allow you to collaborate on a data science team. Um, I'm sorry. Do Somebody's saying they don't have audio. I don't know if that's just him or if hopefully other folks can hear me as well. If you're able
I
to
can
hear me
hear
and you
you.
type, okay, great, thank you. So I guess it's just a problem for him. Thank you. Um, as I was saying, the commercial KNIME server is going to allow you to collaborate with folks on your team. It'll allow you to schedule execution of your workflows and also deploy in a few different ways, including with a web portal, but also a REST API. We release new versions of the KNIME server all the time, but I'm not going to spend a lot of time talking about that because what I'm really more interested in is showing you guys what the KNIME Analytics platform can do. And of course, if you're interested in the KNIME server and you'd like more information about it, please feel free to reach out and we can follow up with you on that. Okay, so the KNIME Analytics platform itself looks something like this. We'll spend a lot of time in live demo, but basically you can see all these different colored boxes here, which are called nodes. I pull them from the node repository, and each individual node performs an individual task. So I have, for example, this file reader node that's reading in some data. I read these workflows left to right. And then maybe I need to do some exploratory visualization. Here I'm building a simple classification model. So I split the model into train and test sets, train a random forest to predict something about my data, apply that model to my test set, and then score it to see how well it performed. Right. So just a really simple example of how I might build a predictive classification workflow. And then there's also several visualizations that we've built into KNIME. If you're familiar with the iris data set, which you probably are, R.A. Fisher's flower data set, then I'm using the scatter plot to plot some different things here. But there's several more interesting visualizations that we can generate in KNIME apart from just scatter plots and bar charts too. The actual workflows themselves, as I mentioned, each node, each colored box performs an individual task. The data flows through the little, what we call ports, the arrows on the left and right of the box here. And then we connect these nodes together to build a workflow that we're reading left to right. And one additional thing we can do in KNIME is actually take, selections of our workflow or even the whole thing if we wanted to, and wrap it up into something we call a component, which is going to allow us to encapsulate complexity for things that we build. So, maybe I build a particular set of nodes that does something like pulls an extract from a table in a database and does some cleanup on it. And it's something that I need to do all the time. Instead of building that workflow from scratch, when I need to do it, I can take what I've already built, put that in a component, and then use that later myself or share it with other folks on my team. Inside the component are whatever nodes that I put in there. And using components also allows me to do some, I can prompt myself interactively to do some filtering or to load from a particular file. I can give myself a little dialogue to be able to basically provide variables. That using a component, if you're used to coding, is kind of like building a library or a function. Kind of, you can think of it like that. Okay. Sorry. There are almost 3,000 different nodes. I think it's even more than that now, available in KNIME. And you can see all the different functionalities that we provide here. Things like, pulling from files. These are our orange nodes reading from flat files or databases, or alternately pulling from big data like you see here on the bottom left. The yellow nodes here are transformation nodes. So things like concatenation, partitioning, joining data together. Green nodes are generally about building models of various types, and this is where KNIME is actually very deep. We have several different predictive algorithms that you can use for classification, for clustering analyses, all sorts of different stuff available to you, as well as Python and R integrations, as we'll see. The blue nodes here, so you can see there's kind of a general color code that we use. The blue nodes are for visualization. Again, you can use KNIME native visualizations. You can use our Plotly nodes that use the Plotly library, or you can write your own R Python code to generate visualizations. And on the right-hand side, deployment. So things like writing files back to databases, generating an automated report, um, sending a model out somewhere so that I can, do predictions against it in a different workflow. All of this stuff here is just kind of showing you in general what KNIME can do. And if you see, 3,000 native nodes and you think, oh, how in the world am I going to learn 3,000 nodes? That's ridiculous. Just know that you can be very, very effective in KNIME using a small subset of those nodes. For what you're doing, you may need to only know, 20 or 30 nodes, for example. So that's just to cover the wide umbrella of the things that we can deal with. I don't want anybody to see that and think that's something that they have to understand fully to be an expert in KNIME. I certainly don't know all of the nodes that we offer, even myself after having worked with it for years. Okay, so if you're listening to me talk and you think this guy, he talks a lot, I'd rather play with the software, be my guest, please. Go to KNIME.com, click on the big yellow button in the top right corner, and you can download the software yourself. We offer for Windows, Mac, and Linux. We're platform agnostic. No limitations on the amount of data that you can process or anything like that. The only real limitation is, what your machine can handle, right? What can my laptop or my server do? So go give it a try. We also have several different courses available. You can go to knime.com/courses to see what we're offering. We also have some free courses available, one of which is at Udemy, which is about 4 hours of video content that will get you started up that initial learning curve of KNIME. We also have several free books that we offer via our KNIME Press site, one of which I'll make a code for available at the end of this presentation, so you can go and download our introductory book. You'll also get these slides. I'll make sure that these get sent out to DICE so DICE can send them to you, and you'll be able to get to all these links pretty easily. Now, once you've been, you're getting started using KNIME, or you've been using KNIME for a while, one of the things that you may want to do is, hey, where can I find example workflows to get started so that I don't have to build all this stuff from scratch? So fortunately, we have something called the KNIME Hub, which I'll show you more of here in a little bit, hub.knime.com. You see some screenshots of it here on the left, which are going to allow you, the hub is going to allow you to get those example workflows, to get components that you may have built or other people have built, as well as access to nodes and their descriptions. So the hub really contains all of the functionality that KNIME offers and presents it to you in a way that's digestible and you can bring right into your analytics platform. We also have a pretty active forum. I myself am on that every day. So along with several of our other data scientists and expert KNIME users. So if you have questions about, why does this workflow not work, or what node do I need to do X, you can come onto the forum and check in with our community, and chances are you'll get a pretty good answer. Okay, so there's about 10 minutes of introduction about what KNIME is, what our background is, some things that you can do with KNIME. So now what I want to spend some time on are some examples and actually show you KNIME in action. So the main demo that we're going to deal with today is this classification modeling demo, and it uses the pretty well-known data set for airline flights. You may have seen this before if you've played around with other kind of classification tasks yourself, or there's several examples on Kaggle and other places that use this data set. So this version of the data set that we're going to use is really a combination of two data sets. It's partially from the US Department of Transportation on-time statistics data from 2009. And what that is it's information on airline flights coming into particular airports. So how long was a flight in the air? Where is it coming from? Where is it going? What carrier is the flight associated with? How much time did it taxi on the runway? Stuff like that. And then we can combine that information with meteorological data from the US National Oceanic Administration. And so that's going to contain things on temperature. Is it raining? Is it snowing? Were there thunderstorms? All that sort of stuff. Why do we care about blending those together? Well, because the problem here, the thing that we're actually going to try and classify, is whether a particular flight is delayed or not. Can we predict departure delays is our task here. And we're going to define a delay as if an aircraft left more than 15 minutes late. So we're essentially turning it into a binary classification problem here. If we were trying to predict how late in terms of minutes something would be, that would be a regression problem, but we'll make it a little simpler and just bin it and say, well, if it's greater than 15 minutes, that's a delayed flight. So in order to go through this process, I'll show you some basics about KNIME and how we would do ETL within KNIME, loading in the data, transforming it, and so forth. We also have some simple visualizations that I can show you. And this is where I also want to start getting into the open source integrations we have, which is really the whole point of this talk. How we do this in KNIME, but also how you could do some of these visualizations in R and Python as well. And so then after we do some exploratory visualization and loading in the data, then we'll build several different models using some of these different tools. So we'll build a random forest using Python with scikit-learn. We'll build a very simple naive Bayes model using R. We'll use a gradient boosted machine in H2O. If you're not familiar with H2O, I'll show you a little bit of that here in a second. We'll use a decision tree within KNIME, and then also we can do logic or logistic regression using a local Spark cluster, which is something cool that KNIME can do. You can actually fire up a little big data environment on your machine using a special node that we have. So I'll show you that too. And then after we build all these models, we'll look and see how they performed against one another. So instead of looking at slides, let's actually switch over to KNIME here. So this is what KNIME looks like when you open it up and get started. Sorry, I'm moving some of my Zoom windows out of the way here. You'll see something like this. So I'll see my welcome back. Kind of looks like a slide here in the middle. This will have links to any updates that you may need to apply in KNIME, also links to the forum, some tips and tricks and things like that. Let me kind of walk you around the interface a little bit before I show you what's going on in this actual workflow. So the top left corner here, this is the KNIME Explorer window. This is where all of my different workflows and workflow groups and potentially data are going to live. So if I scroll down through here, I can see a bunch of different folders that I have. And then down here at the bottom, several different workflows that I've created. And I can double click on any of those and open them up. I also have links to any KNIME servers I may be connected to, like this one here at the top, as well as the KNIME Hub in case I want to upload workflows or components that I build to the KNIME Hub for everyone to access. So this is where my workflows live, is basically the way you can think of it: connections to workflows and connections to servers. That's in the KNIME Explorer at the top left. In the bottom left here is the node repository. This is where all of my different nodes live. So the way that this is organized is kind of in this tree view. If I wanted to go and find an Excel reader node, for example, I want to bring in an Excel file to my workflow, I could go to IO, read, and it's right there at the top. There's the Excel reader, and I can drag that into my workflow. Typically, I don't navigate the tree view to find nodes. What I generally do would be to type into the little search bar Excel, right? And it's going to show me all the nodes that have to do with Excel. There's the reader and writer nodes there. So the node repository is where all of the different nodes live. The workflow coach, I'll come back to in a second. Something else that's useful is over here on the left-hand side. And I guess let me open up a workflow here just briefly. If there's the description pane, this is going to be context-sensitive help for any node or meta node or component that I click on. It's going to provide me all of the different options associated with that node. If I scroll down, I'll see what the different input ports and output ports are. Basically, everything I need to know about using one of these individual nodes is going to be available in the description pane. It's context sensitive, so if I change to a different node, then I'll get different help. This just helps you get oriented, especially when you're learning KNIME, as to what all the different nodes are doing. In the most recent version of KNIME Hub, we also have in this pane on the right-hand side, or the most recent version, I should say, of KNIME AP, the analytics platform, we have a built-in version of the hub here. So I could go to the hub just by going to hub.knime.com in my web browser, which looks like this. That I could search for example, the Excel reader node, right? I could go find in the KNIME Hub, here's the Excel reader itself. I could look for workflows that include the Excel reader. I can look for components that include the Excel reader. All that stuff is here in my web browser. But in the latest version of KNIME AP, the hub is now built into KNIME itself. So if I go in and I search for the Excel reader here, I'll see the exact same information that I just saw in my web browser. But the nice thing here is I can actually drag nodes in directly from the hub. So if I wanted to use an Excel reader, I could click this, drag it over, and bring it. And so now I have a nice Excel reader node here in my workflow that I could start configuring and using. So I could bring that in from the hub. I could bring that in from the node repository. There's several different ways I can bring these nodes in. I can also go and open up individual workflows here in the hub. So you can see it's thinking now. Here's an example workflow that's got my face on it about, how I can, use the Excel reader, right? And if I wanted to actually open this workflow up and start using it, I could, click on the cloud, open it in my local workspace. That would open it here in KNIME, and I could get started. The nice thing about KNIME Hub is that everything that's included here is going to include some sample data for you, so you can start playing around immediately with what's going on with these different workflows and get a better understanding of what's happening. There's a question here I think I saw in the QA. How can I learn all about the node repository? You can just kind of click through the node repository to see what's here. I would recommend, if you're just getting started with KNIME, to see what's available. One of our training courses, whether that's one of the paid ones with one of our data scientists or one of the free ones that we offer, just to go through the process of learning what the commonly used nodes are for ETL, for building models and that sort of thing. I think that's a good way to start. And then as you start to understand better how KNIME works, then you can start asking, okay, what node do I need to do this process? What's it called? How do I read in a PDF file? How do I build a gradient boosted tree? Then you can search the node repository to find those things that may help you. Or the hub. The hub is even really better, I think. The hub is kind of like the node repository on steroids. Okay, so having given you a little bit of a tour around the interface here, let's actually look and see what's going on now in this workflow. Again, this is going to be the workflow that we use to predict airline delays. So if I look at this, this is the top level version of my workflow. I kind of have some of these colored boxes drawn around some of my nodes. You see, I've got this descriptive pane up here. This is called an annotation box, right? I can go in, I can add an annotation box just by right clicking and adding new workflow annotation. I can drag new boxes around. I can double click and, here is some additional text, right? I can change the color. I can make this bold. I can change the font size, whatever I need to do. This is like when you're writing code, you want to leave comments for yourself in the code. Similar concept in using a graphical tool like KNIME. You want to use these annotation boxes to make it clear to other people what it is that you're doing. So, I draw a box around these guys. These are the visualization nodes. Draw a box around these guys in the middle. These are my modeling nodes and meta nodes. Also, not just for other people to use workflow, be kind to your future self and leave good notes and comments for yourself so that 3 months from now, when I open up this workflow, I can still look at it and say, oh yeah, I remember what this does, right? So annotations, we see these kind of all over the place. We also have individual comments underneath each node. So whenever I bring in a node to like this file reader node, if I bring it in from the workflow coach, the node repository, it's just going to have a generic node number under it. I can always double click on this and change it. This node reads from airline to, or whatever, right? I can leave myself in, excuse my terrible spelling. You can add these comments whenever, just as you go, which is another kind of good habit to get into when you're building KNIME workflows. Okay, so we see all these different annotations, and that's great. We see also these gray boxes here. So I talked about a component before. There's actually a component down here at the bottom. We also have something called a meta node, which is what these gray boxes are. Probably don't have time today to get into the difference between meta nodes and components. we do that in some of our training courses. For the time being, you can kind of think of metanodes and components as being the same, in that if I double click, for example, on this data pre-processing metanode, I'm going to go inside now and I have a bunch of other stuff going on. Let me blow this up a little bit bigger. So I have additional nodes contained inside this metanode, along with other metanodes where I could keep drilling down. But the concept behind metanodes is I'm organizing my workflow, and kind of cleaning things up and making things a little nicer to look at and easier to digest for someone who's having to read through my analysis. So if I go inside this very first workflow, or very first metanode in my workflow, I should say, this is the data pre-processing. So everything that's going on here is about reading in the data and doing the initial transformations on it, that we need in order to build models that make sense. So starting out here, I've actually executed all of this already, just so that we have it ready to go for the demo. But one thing that I should point out is under each of these nodes, not the metanodes, but the nodes themselves, you see this little traffic light. And they're all green because I've all executed the nodes already. If I hadn't executed a node already, like here's a node, for example, this file reader, when I first bring it in, this traffic light is red and it has a little warning message on it that's saying, hey, you haven't supplied any options yet. So what that traffic light is indicating to you is the status of the node and whether you need to do anything or not. Here, since I've already executed the node, I know that I'm good to go. But in general, whenever I'm starting out configuring one of these nodes, the way that I do that is by double clicking. So this is my table reader. If I double click on it, this is going to do exactly what it says. It's going to read in a table. This is a .table file is a KNIME specific file, that has this airline data set in it. It could just as easily be, a text tab delimited file or an Excel file or something like that. But in this case, we're using a table reader. And because it's a KNIME native table, all I need to do is browse and point to the location of the file, and it'll read it in. Once I've executed the node, which I have, I can right click on the node and I can go all the way down to the bottom in this context menu and click on read table. And this is going to actually show me, if I blow it up, what's in my data set. So I can see I have about 621,000 rows here, 30 different columns. And what do I have? This is my airline data. So I have things like, timestamp information, year, month, day, for each flight. What was its departure time? What was its arrival time? What was the carrier? And so on and so forth. How long did it spend on the runway? Was it diverted? Was there a security problem? All this sort of stuff. So we're reading this data in, and we get this, big data set that we want to start with, basically. But now, after we've read it in, there's some additional transformations we want to do. So if we, for example, wanted to convert the timestamp, which is in string form, to a date and time form that we can use in KNIME, I can use the string to date and time node. I'm not going to go through every single one of these nodes, but just to give you an example how some of the transformation nodes work, they're yellow. So before, our reader nodes are orange to indicate that we're bringing something in externally from outside of KNIME. And then the yellow nodes are going to do something to our data. In this case, transform a type. So I can go in, I can double click on any of these nodes to open up the configuration dialog. And because this node is doing a different task on the data, the configuration dialog looks entirely different. What I'm telling it is I'm going to do a transformation on this date field. It's got an S in front of it because that indicates that it's a string, and it's in the green box, the include box on the right-hand side. This indicates this is the thing I'm going to do something to. These other string fields on the left-hand side, I'm not going to apply this transformation to. Then I go in and I tell it, here's the format of the particular string. It's 2 days characters separated by a hyphen, then 2-month characters, another hyphen, and then 4-year characters. That converts to a KNIME date and time format. Why do we want to do that? Well, there are some other nodes that we can use in KNIME to be able to later extract things like, day of the week from, or, month of the year from a date field, or we can calculate durations between dates, things like that. That's all stuff that we can do once we've done this transformation. There's other stuff that we're going to be doing here as well. I mentioned that we want to blend that airline data in directly with meteorological data. That's happening in this data blending, for example. If I go in and look at this, I have additional meta nodes that I can drill down into. Here's where I'm reading in, this names of different airports, right? I end up doing some manipulation. I read in, it's called climate data, but it's actually meteorological data here. I'm reading that weather data in from a completely different source. And this is going to contain information like, did it rain? Did it snow? How hot or how cold is it? Things that might have an effect on whether, a particular flight might be delayed. That's contained in this Excel file. So we're going to bring that in and then do things, for example, like a join, a very common type of thing you would need to do. Maybe you would write a SQL query for this between databases normally, but in KNIME, you don't need to write any code. You just specify what kind of join that you're going to do, what fields that you're going to join on, and then you execute. And we start to see as we build down through this workflow, as we're blending in data and cleaning things up, I can check every step along the way and say, okay, what are my new fields that I've added? How many rows and columns do I have now? We've done some filtering in this case to look at just particular um, times of the year. We've added in, before we had 30 something columns, now we have 72 because we brought in this meteorological data along with names of airports and so forth. So one of the general concepts about KNIME that's really nice is after I've executed these different meta nodes or nodes, I can always check and see what the status is at any particular point. So if I look at something and I say, hey, I don't have the right number of columns here, this isn't what I intended to do, I can go back in and check at this point and say, okay, maybe I did my join wrong, maybe I did my filtering wrong. I can go in and make the changes and then just re-execute from this point forward. So I don't have to run my entire workflow all over again. I can just go back to the part that needs fixing, verify that, what's the state of the data at that particular point, and then go about my business after I fix it. Because KNIME is saving the state of the data of each step as we go. Okay, I don't want to harp too much on the ETL stuff that I'm doing here. I think it's probably not as interesting as the modeling stuff anyway. So let's skip to the end of this pre-processing part. Now, normally, if we were doing partitioning and splitting our data into a train and test set, we might use a partitioning node to do that. But the partitioning node in KNIME is going to allow you to do, for example, a percentage split. Maybe I want to do an 80-20 split. 80% of my data goes to the top for training downstream. 20% is held back for my test set for verification later. I can do things like stratified sampling. I can provide a random initialization seed for reproducibility. In this case, we're doing something a little bit different since this is kind of time series data. It's organized by calendar date. So what we're going to do is we're going to say, all right, for January in the year 2007, we're going to take the first 15 days of 2007, and we're going to use that to predict delays on the second half of that particular month. So here, instead of doing partitioning, we're going to do row splitting because we want to split on this particular date. So a little bit different than how we might normally do it if there wasn't a time factor involved here, but that's why we're doing it this way. And so what's coming out of this particular meta node? I have three different things. So I have my complete data set that's coming out so that I can do some exploratory visualizations on it. I also have my training set that I'm going to be using for building my model, and my test set that I'm going to use to see how my model is performing. And so if I back out of this meta node again, I can see that in the data processing, I have these three output ports. So this is my complete data set, my training set in the middle, and my test set at the bottom. And I'm going to be sending this all over the place. So before we actually do any modeling, let's do a little bit of exploratory visualization. So if we follow this top output port from the data pre-processing over here to my visualizations box, I have several different things I can do. So initially I'm using, for example, a data explorer node here. What is that going to do? Well, if I go to configure it, there's actually not much interesting in terms of the configuration. Since I've executed the node, what I can do is go down to this interactive view, which is kind of about midway down through my context menu. And what this is going to do is open up a Chromium browser for me and give me a bit of a visualization that I can look at. And actually, let me make this even wider. I want to make it wider so we can see the histogram on the right-hand side. So this is going to allow me to see at a glance for all my numeric and nominal features, how things are distributed. So if I'm looking at, my departure time, for example, I have my Minimum, maximum, mean, standard deviation, all of these kind of basic statistics are being calculated for each one of these features, along with things like the second and third moments, if you're interested in that. And then maybe more interesting things like the number of zeros in the column or the number of missings, um, which is going to be a good indicator to you of how much you might need to clean something up. This data has already been fairly well cleaned at this point, so that's why we don't see a bunch of zeros and missings across our different features in the data set. The other thing we also see at the far right hand side is just this simple histogram, an indication to us of how much some of these fields might be skewed or not skewed. And if I scroll down, I can see that a lot of them seem actually to be fairly skewed. If I go down to, I don't see the delay column in here. I know it's here, I'm just missing it. Anyway, there is a delay column that is fairly skewed, like a lot of these guys are, where it's basically what we have in this data set are a whole bunch of non-delayed flights and just a few flights that are delayed is what it ends up being. So we can, at a glance, we can see, and I guess I can search for delay. There it is. I don't know why I couldn't see those before. I can see that, my arrival delay, for example, mostly not delayed, but then you have a skewed distribution. So why is that important? Well, for some of the model algorithms that we use, having skewed or non-normal data is not something we want. So we might want to apply some sort of transformation like a log transform or something, or a power transformation, to get things into a less skewed form, so that our models can digest that a little bit better. I can look at other things here too. Like for my nominal data, I can see that one of my fields here is called tail num, which turns out is just the identifier of the aircraft. Is this going to be useful in predicting whether a particular flight is delayed or not? Almost certainly it would not be, right? And KNIME has highlighted for me, hey, you have over 1,000 unique values in this particular field. This may be something you would want to consider not removing, or rather consider removing. It's not going to help you in your prediction. So the data explorer is something that just at a glance, how clean is my data? Do I need to do any additional transformations? Is there stuff that I should remove? We have some other different nodes here that we could look at as well. So within KNIME, I could apply some colors, and then maybe I could build what's called a violin plot, which is kind of a fancier looking box plot, really, to look at the distribution of things. So this violin plot I have separated by delay and no delay. And then on the y-axis here is something about precipitation. So I can immediately see by looking at this, if there's precipitation involved, it looks like my distribution gets skewed out here a little bit more, for my delay class. This is what you would expect, right? For flights that are delayed, I would expect things like rain and snow to show up more often than for flights that are not delayed. So I can immediately see that's the case. And if I mouse over this is a plotly view, I can get the values for, the median and the upper fence and the outliers and all this sort of stuff. So these are native KNIME visualizations, these like the violin plotly nodes that you could use. But you could also, if you wanted to, actually write a little bit of code and then use R or Python views if you're already familiar with that. So if I open up this R view node, for example, it's going to take a second while it opens the dialog. This actually has some code in it, not a lot of code, but this is going to be generating something called a pairs plot. So I can see within this dialog, I have all of my columns that are available to me that KNIME knows about on the left-hand side. And then I won't go through all this code, but it's basically doing a little bit of a linear model fit, and then building the pairs plot to be able to look at correlations between different variables in this data set. And then some stuff here at the bottom about how we want the scatter matrix to look. So I can put all this code here, and I've already executed it. And now I can view what this looks like from the R perspective. So what is this showing me? It's a pairs plot. So it's comparing, for example, the maximum temperature on this fourth row against the snow depth. And I can see that there, as you might expect, is a correlation between how deep the snow is and how hot it is outside, right? If it's really hot outside, I probably don't have a lot of snow. And then I also get the correlation coefficient between snow depth and max temperature, which is 0.49. I could use this pairs plot to be able to see how different variables in my analysis might be related to one another. But that's all done in R, right? It actually turns out there is a KNIME node to generate that plot as well. But when I built this example, there wasn't. So you could generate this type of view in R. Same thing for Python. If I wanted to build a pie chart, I could use, import matplotlib and then build out a pie chart about how many flights on each day of the week, right? There's actually not that much code here. This is almost as much comments as it is code. But just 20 lines of code or so to generate this particular plot if that's something that you want to do in Python. And then I could look at the results. It turns out this is a fairly ridiculous chart. It doesn't really tell you much of anything. Hey, the flights by day of week are pretty evenly distributed. Okay, this isn't something that I would probably normally build a pie chart about, but just to show you, it's more to show you that you can do it than anything else. Okay, I want to keep moving here because of time issues. But what am I showing you? There's different ways to skin a cat, as it were. Use the native KNIME visualizations, use R code, use Python code, however you want to do it and whatever you're comfortable with to be able to do exploratory visual analyses on your data. So now let's talk about how we might actually build models using this data. So here's all the different 5 models that we want to build. As I mentioned before, Python random forest. Let's actually start with the KNIME native version. So here's one that uses native KNIME nodes with the decision tree algorithm. What are we classifying here? Remember, we care about delay or no delay. So we just have this one field that's going to basically say it's a string field, whether something's delayed or not. That's the thing we want to predict. In KNIME, whenever we build models, pretty much regardless of whether we're doing it with native KNIME nodes, regardless of what algorithms we're using, or not, if maybe we're doing it with Python, you'll see that in a second. We use this learner predictor motif. So we have this node up here that we use to train the model using our training set from the top input. And then we have an associated predictor node for that model. So you'll see this all over the place in KNIME. We start with training the model in the decision tree. The most important thing here is we need to pick the class column, which is the thing that we are trying to predict. In this case, it's called depth delay. We have some other options here that I won't go into about tree pruning and things like that to build this model. And then if I wanted to, I could actually go in and look actually at the decision tree view and drill down and see, what are the decision rules that make up this particular tree, and see, what's influencing things, right? So we have views like that, in some cases even built into the KNIME nodes that can help you understand better what's happening with your model. But after we've built this model, we see we have this little blue square, which indicates that we've built a PMML model that contains all of our decision tree rules. That gets passed to the decision tree predictor along with the test data. And when we execute it and do the prediction, what I end up with are my data set with all of my input features, as well as at the far right, I've added some new columns. So I've added a column for the prediction. This is what the model thinks. I want to compare this to the true value. I also end up with the probability of prediction in these 2 columns, the probability of whether it predicts a 0 or a 1, basically. This is going to sum to 1 because this is a this is a 2-class problem. It's a binary problem. So all of these probabilities will sum to 1, but this gives you an indication of how strongly the model thinks it's going to predict something one way or the other. And in fact, we can use these probabilities, and we will soon, to build a ROC curve to evaluate how well the model is performing. So that's one way that we could do it. We end up using a scorer here. I can generate a confusion matrix to see how well the model's performing, and generate things like accuracy, or maybe Cohen's kappa is more important to me as a metric of how well the model is doing. We end up generating 2 things here. I went ahead and kept the accuracy associated with the decision tree, and then I also end up keeping the delay status and the prediction probability so that we can build a ROC curve later. And that's what ends up coming out of this meta node. We're going to compare the accuracies of all these different analyses. We're also going to compare all the ROC curves all at once as well. So if we wanted to use Python, for example, to do something similar, here, instead of a decision tree, we can use a random forest. But we see the same, it's much the same the post-processing for the accuracy and the ROT curve is exactly the same. And then the Python learner and predictor is pretty similar. I just need to go in and write a little bit of code here, import um, sklearn random forest classifier, and then I basically just end up defining some arrays to say these are the input features that I want to use. There are a couple like the tail number that I exclude here. Um, Build out my arrays for my features, tell it what kind of model that I want to build. In this case, it's a random forest with 100 different trees in it, and then fit the model to it. That ends up building the model for me, and it gets passed out of the model port just like it did before to the Python predictor, where I end up writing a little bit more code. Again, here are my features, and now go ahead and apply this model that I just built to the test set and give me the probabilities on how things performed. If I look at the results, it's real similar to what we had before. I get a prediction and a delay probability. So I won't bother going through, how we might build a naive Bayes with R, because it's almost exactly the same thing conceptually, right? It's just using a different algorithm within R. One thing that's probably worth pointing out here briefly is the how we might use logistic regression here within Spark. Not because logistic regression is going to be such a great performer here, and it's actually going to be the worst performer. But it's worth showing you in case you happen to use Hive and Spark in your modeling analyses. We have this node called the Create Local Big Data Environment node, which is really cool, I think. As far as I know, we're the only software package with a graphical user interface that offers this. You can drag this local big data environment node into your workspace, and it ends up creating for you a Hive and HDFS environment and a Spark environment, so that on my local machine, I can, access a database that has my airline data set in it, and then I can use Spark actually to build out a logistic regression model. Why is this so cool? Well, I mean, would I actually be using Spark on my laptop to, in production, build a model? No. But what I could do is I could use a toy data set like this, maybe a subsample of my actual real data set, which lives on a database and it's got 2 billion rows in it. Maybe I do a subsample of 100,000 rows of that, and I build out just a little toy model like this using Spark on my local machine. Well, when it comes time to actually run that model on the big real data set that lives on a remote database, then I can just swap out this local big data environment node to a Hive and a Spark connector that's going to talk to that remote cluster. And all of this processing that's been done, instead of now happening locally on my laptop, is going to be pushed to the database, where I can actually take advantage of the cluster and all the big data capabilities that Hive and Spark offer. So if you're using Hive and Spark, this is a really nice tool to be able to wireframe and do testing on, like I said, local kind of toy data sets before you even worry about what's going into production. It lets you explore using that tool in a way that I think a lot of other data science platforms might not offer. So if that's something that's interested to you, we have lots of workflows on the hub about how you can use the local big data environment. I just wanted to kind of point that out to you. So what do we have here? We have all of these different models. We have accuracies that we've now got from all of them. I, basically concatenate everything together here. And then we have, for example, this little table that says how well are we doing just based on accuracy. Turns out that the H2O gradient boosted machine has an accuracy of 0.97. And then we're sorting descending here. So the next best performer was the random forest, then the decision tree, all the way down to logistic regression with a 0.84. Now, I probably wouldn't use accuracy in this case because this is an unbalanced class problem. And also, since it's a binary classification, I'd probably be more interested in using a ROT curve to evaluate how well my model performs anyway. And so to do that, I could use this ROT curve node, taking all of the different probabilities that we generated before, and I could generate something like this. Again, since this is a KNIME visualization, it takes it a second to fire up a Chromium window, and we can see this ROT curve. For those of you who aren't familiar with a ROT curve, what this is plotting are all the individual observations. It's plotting the false positive on the x-axis, which we want to minimize, and the true positive on the y-axis, which we want to maximize. So as we pull this curve up to the top left corner, the more we can pull it up that direction, the better performing our model is. And then we can calculate the area under the curve. The closer we are to 1, the better the model is performing. If we had these curves that were kind of sitting along this 50-50 line or the coin flip line, then that means that our model is not performing much better than random chance. So all of these models are pulled up to the top left corner. They're all very, very good. If you've done this type of analysis before, they're actually suspiciously good. You very rarely see ROC curves that are this nicely performant, and it turns out there's a reason for that. And we didn't really go over this earlier, but it turns out that there's, in the way that I set this analysis up, there's some leakage in the data set. What does leakage mean? It means that in this case, when you're trying to predict departure delays, if you include as a feature, for example, the arrival delay, you can probably get a pretty good idea of whether something is going to depart delayed or not. So it turns out there's a feature in this data set that shouldn't have been included in the model that's doing the predicting, and that's why these models overperform. They're doing much better than we would expect them to be able to do. So if I were to see ROC curves like this, I would actually not be happy. I would be suspicious. And probably some of you are as well. But just to give you an idea of the way that we could prepare that. And there's even a newer node that we introduced in KNIME 4.2, so not the most recent release, but the one back. No, actually, this goes back to last January in 4.1. The binary classification inspector. So if you're doing binary classification problems, this actually adds on to this ROC curve capability, because what it's going to do is going to combine the functionality of a ROC curve along with a confusion matrix, which I can see down at the bottom. And the nice thing is I can actually change this threshold too. So I can drag the threshold up and down. And as I do that, you see that I'm moving up and down the ROC curve. You can see in this case, my accuracy changed, but maybe instead I'm more interested in, I don't know, the F measure. So I can add different fields up here at the top for things I might care about and see how all of those different things change. I also see my confusion matrix changing in the bottom left here. So basically the idea here is I can, a threshold of 0.5, which is what's going to be used by default by KNIME to do the classification, might not be ideal for getting the best accuracy or F measure or whatever it is that you actually care about. So you may want to change that threshold and play around with it and say, hey, for the Python random forest, what's going to give me the max F measure? It turns out it's a threshold of 0.44, not 0.5. So this just gives you a way to play around with the data, still comparing these different algorithms and results to one another, but being able to change that threshold may give you some insight about how you actually want to select a model in this case. So that's a fun one, the binary classification inspector, if you're doing a binary classification problem to get that view. Okay, my Zoom disappeared for a second. Let me check the questions. Not seeing any additional questions. So let me move on to, since we've got about 10 minutes left, the MNIST image processing workflow. So let's shift gears. And actually, even before I show you this, let me go through a few more slides. So what do we just look at? We saw the accuracy results. We saw this very suspicious ROC curve, but this is what we got from this particular workflow. And if you're interested in actually doing this yourself, there's a link in the slides to the workflow that I just showed you. You can download it from the hub. You can execute all these nodes yourself and look at the results and play around with it and see how you might do things differently from what I did. We mentioned the local big data environment here, so I won't harp on that, but just know that it's interesting and I think fun to play around with if Spark is something that you use in your day-to-day. Even going further, we didn't talk about H2O very much. If you don't know what the H2O algorithms are, H2O is another open source kind of group of guys out in Berkeley, California, and H2O is very much about producing performant algorithms that scale with a large data set. So if you're using H2O algorithms, you're using really fast executing algorithms. And we actually have nodes for those built into KNIME to be able to use H2O. And even further, you can use H2O nodes within Spark. And so that's what this slide is talking about, sparkling water combining the power of H2O and Apache Spark together. You can do all of this within KNIME without writing any code. So again, this is more on the big data side, but if this is something that you're interested in doing, we have other workflows out there that go into more detail about how this works, and why you'd want to use it. You'd want to use it because it's really fast. Some other stuff that we didn't talk about for the Python integration. I just briefly showed you, how we can build models with Python and apply them, how we can do some simple visualizations with Python. It turns out that you can arbitrarily execute Python within KNIME. And in fact, you can call Jupyter notebooks, if that's how you like to use Python. You can call those from KNIME directly using the KNIME Jupyter package. So you can reach out and execute a Jupyter notebook, but you can also go the other direction, it turns out. From within a Jupyter notebook, if you want to, you can use the KNIME Python package to turn around and execute workflows that are on the KNIME Analytics platform or on the server. And when you do that from within Jupyter Notebooks, you even get a little image of what the top level of the workflow looks like. So this is a nice way to be able to, if you have things that you prefer to do in KNIME and you have other stuff that you prefer to do in Python, you can still blend them together really well. And we have good examples of how that can be done available on the hub. I just wanted to show you a few slides on this because I think it's interesting functionality and we didn't really get into it in the example. So here's links to everything when you get the slides later, about the airline workflow, some stuff about this big data, Spark, H2O, Python integration, and Jupyter integration. Okay, let me just briefly, we've got about 7 minutes left. I'm going to show you how you can approach deep learning with Keras using a TensorFlow backend in KNIME. So why would you want to do deep learning with KNIME? One of the nice things about it is KNIME really makes deep learning more accessible, especially for non-experts. So if it's something you've always been interested in, but you weren't sure where to start, and you didn't want to really have to learn all the Python syntax and everything to do it, you can use KNIME to learn a little bit about deep learning because you can build out your networks visually using our nodes. We have the ability to do all the data pre and post processing that you would need, fine tune and train those model architectures, and even ultimately deploy them if you want to. And so in the example that I'm going to show you here, we'll use the MNIST data set. If you are familiar with CNNs and doing image classification, convolutional neural networks, you probably have seen this data set before because it's kind of a classic one. The idea is we have in the bottom right corner all of these handwritten digits. Somebody wrote the number 3 or the number 5 or whatever. We're going to look at pictures of those handwritten digits, and we're going to build a model that's going to classify them into what they are. So it's going to look at the number 3 that someone wrote and go, that's a 3. And hopefully it doesn't say that's an 8. Although sometimes it will get it wrong. So how do we do this within KNIME? Let's look at the workflow. So there's a couple of different ways you could do it. If you're used to Python syntax already and you wanted to build a convolutional neural network with the appropriate layers, you could do that using the DL Network Python creator. And this is kind of similar to what we saw before, right? You're going to be writing, 30, 40 lines of code or something here. I'm going to import Keras. I'm going to import all these different layers. I'm going to define the layers and their associated shapes and what their dimensions are, what my activation functions are, all that stuff, just write some code. It's not terribly complicated code to set this up. This is not a super complex neural network, but still, if you don't know the syntax, this can be frustrating to get through even this 35 lines of code. So there's a different way that you could do it. You could use our Keras nodes here to be able to say, for example, I'm going to start with an input layer of dimensions 28 by 28 by 1. Our input in this case is a 28 by 28 PNG. Each one of these individual images is a PNG file with these very particular dimensions. So I can define my input layer. I can define, my convolutional layers to say what I want my kernel size and strides to be, what I want my activation functions to be, add in a dropout layer to prevent overfitting, do some flattening, and then eventually in my last layer here, I'm going to have a 10-unit output layer. That's going to be for the digits 0 through 9, because that's ultimately what we're trying to classify. And then another activation function. So there's several layers going on here, but this produces the exact same network as what we just saw with the code snippet that I showed you. But here you have the ability to click through and define everything. So it's a little bit more palatable if you don't know the syntax, as I mentioned. So what we're bringing in here for this is 10,000 different MNIST images for the training data. And then there's 1,500 images for the test data. We use our Keras network that we built with the 9 nodes to feed to the Keras network learner. We go in and we say, hey, we're going to basically, what are we using? We're using this particular image file. What is the target? What are we trying to predict? The digits 0 through 9. And I've already run this already. This took about 5 minutes to run on my laptop. But when it's running, you'll actually see something like this. You'll see the accuracy values scrolling down the side as the model trains itself. You'll see the accuracy increasing. I'll turn on the log scale and the smoothing. You'll see the accuracy increasing as it goes, and you'll see the loss function, if you prefer to look at that, decreasing, right? So ultimately, once this thing completes, it ends up with an accuracy, north of 0.99 after only 5 epochs with 50 patches. So it ran about a minute and 30 seconds. So that's even quicker than I thought. So it takes this output from the neural network that it's trained, feeds it to the executor. Again, we see this kind of learner predictor motif that we see in KNIME for all sorts of stuff. And then since we're almost out of time, what do we ultimately end up with at the end? Here's a confusion matrix that shows you each individual digit and how well it was predicted. So our overall accuracy here is about 93% after 90 seconds of training a model. That's pretty good. And then we can see in individual spaces where it doesn't perform as well. Like for the number 8, we seem to have a problem compared to the number 1, for example. 97% for number 1 versus 83% for the number 8. And I could even go in and look at individual images and see, oh, hey, this guy right here, it detected a 6. It was actually a 5. Well, if I look at that, that looks like a sigma to me, so I don't necessarily blame the model for getting that one wrong. But I could go in and look at all of these individual images and see, if there's anything maybe I should go back and think about tweaking in my model setup to be able to predict this stuff better. Okay, so I think we're almost out of time here. Let me just, we don't have time for the text analytics demo. Sorry about that. I did want to show you this. So if you go to knime.org/KNIMEpress and use this promotion code DICE-1220, 1220, you can get a free copy of the Beginner's Luck book. It's kind of like a textbook that'll walk you through getting started with KNIME. And because it's kind of like a textbook, it also has a set of workflows that come with it and exercises to, it'll teach you a concept and then give you some example problems to work on. Then look at the solution. How did I do? So it's a good start to actually getting your hands dirty with KNIME and using it in an interesting way. We also have several other books out there as well, but this is a good one to get started with. We normally charge a little bit for this, but if you use this promotion code, you can get it for free. So I wanted to make that available to you. If you have any other questions about what I've shown today, sorry I had to go through pretty quickly here at the end, but I'm happy to answer any questions. Thanks for your time. Let me see here. It looks like there is one question. A few words regarding model deployment and transforming back in Python, if possible. Yeah, so I didn't get into model deployment at all, really. There are several different model writer nodes that we could use. Some of them are generic and some of them are more specific to Keras. There's the model writer. There's also things like the TensorFlow network writer, the Keras network writer. There's an Onyx writer in here somewhere. I may not actually have that installed right now. But once you build a model like this, you can write it out and then use that model in a different workflow to do predictions against. And in fact, if you were to use KNIME Server, one of the ways that we recommend deployment is putting your written model in a workflow in KNIME Server and then using the REST API to, basically you send new data to that model using like a JSON. The model reads it in, gives you a prediction back as JSON. And if you're using the REST API on KNIME Server, that can happen really quickly. So that's one way that you could deploy. There are several other options too. We have something that we've introduced called integrated deployment, which I didn't have time to get into today, but that's a feature that will help you automatically build your deployment workflow as you're building your model workflow, which is a really cool feature we just introduced this past summer. So integrated deployment, you can check that out. We have some talks about that online too. Um, but yeah, there's several different ways you can get a deployment. Mostly I would write out to a different workflow my model that I just built, and then probably use the REST API on KNIME server. Any other questions? I'm not seeing any in the chat here or in the Q&A. Okay, I think since we're over time, I'll go ahead and stop, but please come visit us on the forum or on our socials if you have any other questions. Also, Dice Analytics is a KNIME partner, and they have lots of good KNIME knowledge as well, so you may want to reach out to them directly if you have questions about how to use
I've also
KNIME.
mentioned an email address in the chat section as well. So anyone who requires recording or have any questions, please feel free to email us. I guess that's about it for the webinar. Thank you so much, Scott. We had a terrific time on this webinar with you. To all the attendees, please do check the chat section. I have mentioned the email. Feel free to email us. All right. I think that's it.
Thanks, everyone.
Thank you
Appreciate your
so
time.
much, Scott. Appreciate
All right,
your time. Thank you. Allah Hafiz.
all right. Bye-bye now.